You pick up a guitar for the first time at 34. A friend laughs kindly. Should have started as a kid, they say. Your brain's not built for that anymore. You've probably heard some version of that your whole adult life. Learn a language after 25 and you'll always sound like a tourist. Quit a habit past 40 and good luck. The wiring's basically set. The building's finished. You just live in it now. Maybe you felt a smaller version of it too. A new skill at work you told yourself you were too old to really get good at. A sport you figured your brain, not just your knees, had aged out of. For most of the 20th century, neuroscience agreed with the joke. Textbooks taught that the adult brain got wired once, in childhood, and after that it only had one direction left: down. Then a handful of strange experiments quietly proved the textbooks wrong. Scientists gave the brain's ability to physically rearrange itself a name: neuroplasticity. Not plastic like the material, plastic like the older meaning of the word, capable of being molded, shaped by pressure, and holding the new shape afterward. New connections. Strengthened pathways. Sometimes a whole region switching jobs, and the first real proof of it didn't come from a philosopher's guess. It came from a knife, a monkey's hand, and a scientist patient enough to wait. In 1968, a young researcher named Michael Merzenich worked with two neurosurgeons on an unusual project. They cut the nerve bundles in a monkey's hand and stitched them back together, deliberately scrambled. Then they waited months and mapped the monkey's brain. For decades, the reigning idea in neuroscience had a name too: localizationism. Every function had its one fixed spot, wired at birth, and that was that. Here's what should have happened, according to the textbook. Each patch of skin reports to one fixed patch of brain, wired at birth and locked in for life. Scramble the nerves and you'd expect a scrambled, useless map. The brain still listening to the wrong wires, forever. That is not what Merzenich found. The map had redrawn itself. It matched the new, scrambled wiring almost perfectly. Picture an office directory listing which floor each department sits on. Move accounting to the 3rd floor, and eventually the directory gets updated to say floor 3. It doesn't keep sending mail to the 2nd floor out of loyalty to how things used to be. Merzenich kept going. Through the 70s and into the 80s, he and his colleagues cut and even amputated fingers in adult monkeys. In one study, a monkey lost a finger. Within a month, the cortical map for that finger's neighbors had crept in and claimed the space. Researchers had assumed you needed a young, developing brain for anything like that. These were fully grown adults. The idea itself already had a name by then. A Polish researcher named Jerzy Konarski had coined neuroplasticity back in 1948. Donald Hebb popularized the underlying learning rule the following year, in a book neuroscience students still read. The shorthand neuroscientists still use for Hebb's idea is, neurons that fire together wire together. William James had speculated about something like it as early as 1890, decades before anyone could prove it. What Merzenich supplied wasn't the word, it was the evidence. So the adult brain wasn't the finished building the old model described. It was closer to a map that kept redrawing itself, based on how it got used. Which raised an obvious next question. Could you see that kind of rewiring happen in an ordinary person, without cutting anything? The best answer came out of London traffic. To get a black cab license in London, a driver has to pass something called simply the knowledge. The test dates back to 1865, when horse-drawn cab drivers were required to prove they knew the city without a map. It hasn't gotten any easier since. The layout of over 25,000 streets, plus every landmark near them, memorized well enough to plan a route on the spot. Most trainees take 3 or 4 years to pass. Roughly half drop out before they ever sit the final exam. In 2000, a researcher named Eleanor Maguire scanned the brains of licensed cabbies and compared them to people who didn't drive taxis. The taxi drivers had a noticeably larger posterior hippocampus, the part of the brain most tied to spatial memory. And the longer someone had been driving, the bigger it tended to be. That alone doesn't prove much. Maybe people with naturally large hippocampi are just drawn to jobs that reward a good sense of direction. So, in 2006, Maguire ran the comparison again, this time against London bus drivers. Same stressful traffic, same long hours, but a fixed route every day instead of a city's worth of options. The bus drivers didn't show the same hippocampal difference. Building the mental map seemed to matter more than simply driving for a living. Even that left a question open. Had the training actually changed anyone's brain, or had it just filtered for people who already had one? The cleanest answer came in 2011. Maguire's team scanned 79 trainees before they started studying the knowledge, then scanned them again 4 years later. 39 had passed. The rest hadn't. Only the ones who passed showed measurable hippocampal growth. The trainees who failed, and a group who never trained at all, looked the same at the end as they did at the start. Picture that scan room on day 1. Dozens of brains, side by side, statistically indistinguishable. 4 years later, only one thing separated the ones that had visibly changed from the ones that hadn't. Which of them had spent years building a mental map, street by street, one wrong turn at a time? So the brain really can grow new structure in response to sustained, demanding practice. Not overnight, and not from wishing. Which brings up the part the more optimistic version of this story tends to leave out. In the 1960s, 2 researchers named David Hubel and Torsten Wiesel ran an experiment on newborn kittens that would later win them a Nobel Prize. They sewed one eye shut for a matter of weeks early in the kitten's life, then reopened it. That early window in a kitten lasts only a few months. Miss it, and the door doesn't reopen. The eye itself was fine. The connection to it wasn't. The visual cortex territory that should have belonged to that eye had been taken over by the other one. The kitten stayed functionally blind in the closed eye. Permanently. Even though nothing was wrong with the eye anymore. Do the same thing to an adult cat, and nothing happens at all. The window for that particular kind of rewiring had already closed. So plasticity has a calendar. Some systems get a narrow early window where change is enormous, and once that window shuts, they're remarkably hard to move again. Even the plasticity that does stay open in adulthood isn't free once it's earned. In 2004, researchers taught adult volunteers to juggle 3 balls for about 3 months and scanned their brains before and after. The region that grew was one tied to tracking motion, the kind of thing your eyes do constantly while juggling. Then the volunteers stopped practicing. 3 months later, the growth had partly reversed. The brain hadn't just changed once and settled. It kept tracking whether the skill was still in use. None of this means adult rewiring is a parlor trick, though. A neurologist named Edward Taub built an entire stroke rehabilitation method on the opposite bet, that even a badly damaged adult brain could still reorganize itself, given the right kind of forced practice. Taub had spent years first proving the same principle in monkeys with disabled limbs before adapting it for stroke survivors. His method restrains a stroke survivor's healthy arm in a sling for hours a day, forcing them to use the weak one for every task, however clumsily. Patients who'd been told their arm would never fully work again regained real function, sometimes years after the original stroke. Brain scans showed the motor cortex reorganizing right along with the recovery. The American Stroke Association eventually recognized the method as a real treatment, not a fringe idea. Between a kitten's shut eye and a stroke patient's slinged arm is basically the whole real story of an adult brain, capable of real physical change, narrower than a child's. Never permanent without upkeep. Put those 3 findings next to each other, and a pattern falls out. Merzenich's monkeys show the adult brain's map was never actually fixed, just assumed to be. The London cabbies showed that sustained, effortful practice can write new structure into that map. Not talk yourself into it. Actually do the thing badly, for years. And the kittens, the jugglers, and Taub's stroke patients showed the limits. Plasticity narrows sharply after certain early windows close, and even the plasticity that remains fades without continued use. 4 years of the knowledge. 3 months of juggling. Months of a slinged arm. Every real case had a number attached to it, and the number was never overnight. That's a very different story than the one sold in a lot of brain training ads. Nobody rewired a hippocampus over a weekend. Nobody in these studies did a 15-minute exercise and unlocked a new cortex. Every documented case took months of repeated, effortful, often frustrating practice. And every one of them was measured with an actual scan, not a feeling. Nothing in this story fits on a supplement label. The version of plasticity that holds up under a microscope is slower and less magical than the marketing version. It's also, somehow, more useful. It means the door to a new skill doesn't fully close at some arbitrary birthday. It just gets heavier. Which brings us back to that 34-year-old with a guitar. They're right that it'll be harder than it would have been at 8. Some of that early childhood window really is gone, the same way it was gone for Hubel and Weasel's kittens. But harder isn't the same as closed. Cortical maps still redraw themselves in a grown adult, the same way Merzenich watched them redraw in a monkey's hand, the same way a cab driver's hippocampus grew, one memorized street at a time. It just takes the unglamorous part nobody puts in the ad. Months of actually playing the thing badly, on purpose, over and over. The way the trainees who passed the knowledge kept driving the same wrong turns until they weren't wrong anymore. That's not a myth built to make you feel better. It's what a scan shows. So here's the question worth sitting with. What's the one thing you quietly filed under too late for me that was never actually about your age at all?